Hello there everyone, and welcome back to Kerbal Space Program, Flyer's Ed. We're in episode 5, and we are here once again with Mr. Pfister, our instructor.
Good afternoon, class. How are you today, sir?
Not too bad, not too bad. Ready to send this crazy thing to the moon.
We're going to send this crazy thing to the moon, and we're going to do what others would think is too hard, and that is rescue 3 stranded Kerbals.
And the ship they're in.
We're going to try to accomplish that too.
It's...
The good news is that they're Kerbals, and if they die, our lawns will be greener as a result.
Indeed, indeed. So, we were discussing before we started recording, the flight engineer, what is the most useful thing to have open for launch?
Let's look at Vessel. Because this is a very unique mission profile that we almost had to... We didn't cheat the game, but we needed to impart information to the flight engineer that is very difficult to impart, and that was offloading Delta V to another vessel. So we used test weights, and we added and subtracted, and we used the Delta V chart. So
Yeah.
Because of all of that, I think it will be more important on this launch than on any other launch that we be able to watch this readout.
All right.
Rendezvous we're not going to be worried about. Let's look at surface and orbit.
All right, surface. We'll just get rid of vessel from...
Sure. Surface by itself for the moment. That's showing us our current altitude. That is the altitude of the control module active. In this case, it's our one-man can.
All right.
Our altitude above terrain from the same reference point is 8.2 meters.
Yeah.
We are moored to the ground with our clampy clamps. And impact, longitude, latitude, that's effectively our current location. And at this altitude, terminal velocity is 95 meters per second. That is going to become important, mostly because that number is going to change.
It's going to go
Terminal velocity, yes it is, but it's going to go up exponentially. It's going to go up initially very slowly. Terminal velocity is what happens when you put your flat hand out a car window on the highway or when you go skydiving. We have acceleration forward from the car or downward from gravity in the two respective metaphors. And we have opposing force in the form of air resistance.
Right. And air resistance on a rocket ship that's trying to power through the atmosphere is a significant problem.
Yes. Now, terminal velocity means that's when the two forces will achieve equilibrium. The only way you can go faster than 95.407 meters per second in any direction right now from this point, 360 degrees horizontally, and 360 degrees vertically, other than the slight detail, the fact that if we go straight down, we'll impact the launch pad, is by applying wasted amounts of energy in the form of thrust.
Okay, so basically those big absurd ships that you've seen for that competition Scott Manley put together are bypassing that by just having that much thrust. You've seen that competition.
Oh yes, he doesn't call it physics.
It's the race to space. I think it's yeah. But anyways, I digress.
Yes.
Yeah.
Atmospheric efficiency. All of those are great things that will become more or less important as we go on. Our current biome. We're in shores. Blah blah blah. Let's see orbit for a second.
Okay. It's not going to tell us a lot in this context, but
you're correct. This is stuff that we're already a little bit familiar with from other mods or just from going out to the map view. Right now, our apoapsis height is our current altitude because we're stationary. What does our periapsis height mean?
Basically, it's almost meaningless, but I think it's sort of a measure of. Basically, that's pointing towards the center of the planet for all intents and purposes.
Yes, because the planetary radius, if I'm not mistaken, is 600 kilometers for a diameter of 1,200. This is a periapsis height of negative 598.5 kilometers. This means that, let's pretend that the gravity acted the same, but our launch clamps disappeared and we could literally fall through the hollow planet.
We'd fall right down to the center of the Earth and then come swinging back up to a height of 80.76 meters.
Exactly correct. And we would be developing a lot of angular momentum in the process too.
Yeah. So, shall we get this show on the road?
Let's get this gong show on the road. Let's leave Orbital and Vessel.
Okay, there we go. All right, full throttle to the engines because everything's been tuned appropriately. Correct?
And that's correct. Before we ignite, our game plan is going to go. We're going to activate SAS right now, as a matter of fact.
Done.
We have no SAS module on this craft except for that endemic to the pod. We might have to revise this plan with an SAS control module. So, if that's the case, that's the case.
All right.
We're going to head straight up until we hit an actual altitude of 10,000 meters.
And then we'll start turning.
Once we've achieved... we will turn all at once, because this is stock aerodynamics. We are going to turn all at once to heading 090, angle of attack 45 degrees. So due east, but 45-degree angle.
Yep.
And then we're going to no longer pay attention to our actual altitude. We're going to pay attention to our apoapsis height.
Okay.
When our apoapsis height achieves anywhere between 80 and 100 kilometers altitude, we're going to cut throttle and prepare for circularization burn at apoaps.
Alrighty. Let's roll.
Let's roll.
In 3, 2, 1. Lift off.
There we go.
Looks good. Oh boy, it's are we accelerating too fast here?
We might be, but let's run it out if for no other reason than as a test.
Okay. Because it sure feels like we are punching through the atmosphere with great enthusiasm right now. Oh, there go the... Get rid of those.
Yep.
Oh, we're losing speed.
We are losing speed. What is our thrust to weight ratio? It's Alright, so if we make it, we make it, but we lost a lot of delta V to atmosphere right then.
Yeah, we overthrusted at the start.
Yep. Pay attention to altitude. We're approaching our turn vector.
Yep. Yep. Here we go.
Hard starboard. Yeah, during the time lapse of the previous episode, we were having a hard time coordinating the thrust to weight limitations of the solids to the radials and burn times and other unmentionables. And unfortunately, to get it the way we wanted, it would have involved bringing the solids down to 0 thrust, which was completely retarded.
Yeah, we probably should have taken them down a bit lower than they were, though, from the looks of things.
Or left them the way they were, but like 2/3 throttled it.
Yeah.
We'll reassess once we're in orbit. This is not an Iron Man career save. This is Flier's Ed. So we are going to be completely willing to revert to launch.
Yeah, learning by doing.
Indeed.
So apoapsis of 1,000, just about 20,000. So
it's looking more and more like we're going to have to revert here because
I think so. Well, we're already.
Yeah, let's revert to launch.
Okay. Revert to launch or vehicle, or we're gonna do some work in the. Okay. So we need to tweak those.
Yeah, I suggest reverting to launch so that we can experiment with our control variables before we start experimenting with design variables.
Okay. So you're thinking launch with lower. We could have the thrust on these lower. On the
so
liquid.
let's leave the throttle the way it is.
Okay.
Let's turn our SAS on.
Okay.
When we stage away our solids, at that point we're going to Z up to full throttle.
Alrighty. Sounds good.
Other than that, turn program is the same.
Okay, here we go. Launching in 3, 2, 1. Okay, still going up. Really fast. Did we even thrust limit these? I can't remember now. Well, I guess we'll see.
Pay attention for stage timing.
Yep, I'm watching. All ready to rumble.
Alright, kill orbit, give me surface. On the engineer.
Orbit off, surface up.
Terminal velocity.
154. We're
a lot better than where we were, but we overcompensated.
Yeah, we just hit equilibrium right there in terms of our thrust, in terms of the atmospheric efficiency or drag, I guess. So we did lose some speed again.
Well, that's correct. Our first attempt's problem was that we lost way too much of our delta V to atmosphere because we were at almost a full twice terminal velocity. So as soon as we blew off our solids, we lost it to aerodynamic drag again. Here we compensated by going to 50% throttle. We didn't lose it to terminal velocity, so we were a lot better, but after we staged, we started losing it again to gravity because we still slowed down by almost 40% of what our upward velocity at time of stage set was.
Right. So we're still going to be a little short, aren't we?
Let's kill surface, go back to orbit.
Oop.
And stage.
Yep. Done and done. Oh, we're still accelerating this time, which is good. We lost a little bit of speed the last time, if I recall correctly.
Yep.
Well,
we need to land with somewhere around 2,000 delta V.
Yeah.
That means we need to get into lunar orbit with somewhere around 2,650 delta V. That means that we've got to get into LKO with somewhere between 34 and 4,000.
I'm not sure this has quite got the guts to do that, does it?
No. It's possible.
Possible. I mean, we've just hit. Our apoapsis is only 300 meters ahead of our current altitude. I mean, it's starting to accelerate now, but okay, we're about to lose the bottom stage. We're going to start using our.
Let's keep going. We're definitely going to revert, but right now, what's interesting is time to apoaps. What we're going to do is we're going to play with our throttle setting at liftoff.
Okay.
And we're going to play with our turn profile after stage. And the way we're going to play with our turn profile is we're going to continue to make our turn at 10,000, but we're going to determine our turn angle with the time to apoapse. We
Okay.
want to keep it somewhere between 20 and 60 seconds.
Okay. Sounds good. We just passed 30 seconds there, so...
And yeah, we're nowhere near where we need to be. Let's revert to launch.
Yeah. Revert to launch. Launch simulations.
Mm-hmm.
Interesting. All right. So we could launch with an even lower thrust than we did last time, because I think the solid rockets were actually still giving us more than we actually needed.
No, because what we... All right, attempt 1 was max throttle.
Yeah.
Attempt 2 was the current setting of 50% throttle.
That's right.
With max throttle, we lost that excess delta V to terminal velocity. With this, we harvested back that terminal velocity loss, but we re-lost it to gravity.
Right.
We need to get up to 10,000 meters as quickly as possible without plowing through the atmosphere.
All right.
So, let's increase our current throttle to 2/3.
Okay, there we go.
SAS.
Yep. And
Launch when ready.
in 3, 2, 1, lift off.
Time to lapse. Approaching 10 seconds.
Yep.
Current delta V sipping down towards 61,500. And increasing. Wow, okay.
You sure we're not... Surface shows us the...
Yeah, give us surface.
instead of orbit. Yeah, there we are. Yeah, I think we were passing terminal velocity there, because... Yeah, I'm pretty sure we had passed terminal velocity on our launch there.
Let's revert to launch. Let's see if you're right.
Because it's only 140, and I'm pretty sure we passed 140 on that launch. But it's time to check. Okay, so 2/3 is what we launched at.
Yep.
Right?
SAS.
SAS, and 3, 2, 1.
After booster step, we're going to switch from surface to orbit.
Okay.
Terminal velocity 102, 105.
We have just passed it.
Nope.
We're at 127, and we have flown past terminal velocity.
All right, Vert.
So we need to dial back those boosters a bit,
Not necessarily.
or our throttle.
I wanted to work with our throttle more.
Whoops,
but
sorry.
We're going to the VAB. We might as well do something with it.
Yeah.
What is the current throttle setting on the boosters?
100%.
At a thrust to weight ratio at ignition of 2.5. Give me between 75 and 80.
There we are.
All right. That gives us 2.10. Okay, so 213
Yeah.
with a 1.4 handoff from 3. Solids will burn for 40. The liquids will burn... Is that 60 seconds after solids jettison, or is that 60 seconds after they ignite, which means we only have booster flight for 20 seconds? 18 seconds.
Couldn't tell you, but based on what we've seen, I think it would be 60 seconds after set. No, you know what? It would... I don't know.
Yeah.
I actually don't know the answer to that. I couldn't... I guess we'd get a stopwatch out and see what happens after separation.
The other possibility while we're in here, let's hit the propulsion tab.
Okay.
Do we have any higher thrust engines that are the same diameter for the center stack? Because our problem is the center stack.
Okay, higher thrust than the LVT-30, I think is what we were using. That's an LVT-30, isn't it?
think.
Do you remember?
No, I think it was the 45, because remember we wanted gimbaling?
Right, it was. And that's 200 versus we could put on the no gimbaling LVT 30. It's 15 more, it's a kick of 15 more units.
It's a kick of 15 more units with a mass savings of a quarter ton. 1.25
yes, it
to
is.
1.5.
Yes, it is.
Why not?
We might be okay because the mass reaction wheels seem to be pretty effective on this thing.
Let's save.
Yeah. And we knocked those down to 76. Oh yeah, look at our... Hold on. What's gone wrong here?
Mouse over... yeah.
There's your problem.
There's your problem?
Yeah. Be a little late to fire off the central engine, wouldn't it? Anything else? Right. Or we... To the launch pad?
So all of the liquid engines are at 100, right?
No. The outer ones are at 45, or at 40.
Leave that. The inner that we just messed with is at 100. That's good.
Yep. And these guys are at 76.
Give me between 68 and 71. 2.7, 3.4 to 1.5. I like this. Save it.
Okay. Let's do it.
Yep.
All right.
I gotta say.
Mm-hmm.
Yep. I gotta say that with the figures that I've been spouting, my mind works a lot faster than my mouth. You can tell sometimes I stutter. And I want to remind the viewers that I'm not in control of what we see.
Yeah.
I am being Skyped in from 3 time zones away with a 2 or 3 second time delay, no less. So I have to, if I were just, in control of the interface, without being able to verbalize what I'm doing, I could flow through the controls because I'm used to it. I'm trying to verbalize what I do because that's my only method of control over the screen.
Yeah.
And I'm trying to verbalize what I do for benefit of the viewers because this is Flier Zen. So
this is how we learn.
Yes, people following along with a notepad will find substantive mistakes in some of the figures that I spout. But in my defense, I'm usually within at least the standard deviation of the correct answer. And when we're off, I have a feel for we're off in what direction. Okay. So let's leave it at 2/3 throttle. Let's leave our SAS on.
And let's
we
see
are
what
going
happens.
to launch with vessel and surface. Once we jettison solids, we're going to switch from surface to orbital. While our solids are ignited, we are going to be paying attention to our terminal velocity. I'll be calling out the terminal velocity verbally. That's where my eyeballs will be locked.
Okay.
The student Gordon will be calling out increments of velocity from the Nav Ball because he's responsible for the Nav Ball and making sure that we remain upward and vertical until our gravity turn at approximately 10 kilometers.
Sounds good.
When we do our gravity turn at 10 kilometers, we are going to judge our turn angle at that point based on time to apoapse at the time. If we have an exceedingly safe time to apoapse of 30 to 60 seconds, we are going to head all the way over to 45 immediately. And the closer we are to like 10 or 15 seconds time to apoapse, the closer we will remain to vertical.
Sounds good. Launching in 3, 2, 1. Liftoff. Okay.
Terminal velocity 100, approximately.
50 meters per second.
Hitting 100
70,
now.
70, 80 meters per second.
105.
90 meters per second.
110.
100.
115.
110.
120.
115. 120.
125.
125.
130. State SEP approaching.
130. 135. 140.
138.
150.
145. Not bad.
Better.
Room for
Okay.
improvement, but it'll be very difficult to get all of that improvement out. So
We are
we'll
losing.
work on it, though.
We just hit equilibrium. We lost a bit of speed on that. Our handoff, that was the best handoff yet, though. But
All right. At this point, that means our
boosters are still just a tiny bit more powerful than we need.
and our liquids are a tiny bit weaker than we need. Time to apoapse currently 1.7.
Yeah. Just coming up on our time to turn, which means we're not going to be doing a... Oh, crap, crap, crap.
No.
Wrong button. Yeah.
Yeah, revert to launch.
I bumped the space bar. That was a...
Well, don't do that.
Yeah. It happens about once in a blue moon during my LP series, during the Better Than Starting Man series as well, so...
It happens to the best of us, and it also happens to me, so we're not worried about it.
Yeah.
Let us go with a throttle of 1 notch below 2/3.
So, about there then.
Yep. SAS.
Okay, and 3, 2, 1.
Negative.
Oh,
Negative.
hold on. Okay.
Surface.
Right. There we go. All right.
Go.
As I was...
Go for launch.
3, 2, 1. Launch. $50.
100.
75.
105.
90.
110.
100.
115.
110.
120.
115.
125.
125.
135.
135.
140. Nice.
Still just a tiny short. We're losing our there's our equilibrium.
Keep going.
Yeah.
Switch to orbital.
Yep.
To fix that, we would need to slightly tweak upwards our radial engine throttle.
And then we would
doing
have to...
that because we would upset the equilibrium that we found on ours.
Yeah, we would.
Not necessarily. We could compensate for that with the throttle.
With the thrust limiter on the boosters, you mean?
Well, no. Approaching turn. 20 seconds. Suggest angle of 35.
10. So that'll be about there.
That's 20.
That's 20. There. Oh, there we are. That should be it.
Yeah, that's 35.
Yeah. There we go.
Hello.
What was that?
45.
Okay. Oh yeah, it's definitely a little more sluggish to turn with these with the no gimbaling on it.
That's right.
It still works, but it's just a little less responsive.
And we are losing speed, so we need. Ooh.
Speed or time to apoapsis?
We're both, but we're losing time to apoapsis. We are hovering at 21.5 solid.
Okay.
So to fix what's going on in the early launch profile, the consensus is to slightly increase liquid radial thrust, leave solids alone, launch with a lower throttle setting.
Okay.
that will actually, well, it...
Yeah. There we go. Time to apoapsis is looking better now, but...
Yep.
The question is, are we going to have enough when we hit orbit with this design currently?
Yeah.
I'm just trying to figure out if we're trying to squeeze water from a stone here, or if this thing will actually be able to do what we want it to do. What do you think?
I'm thinking and I'm watching numbers as we go because now we need information from this flight regime. Let's transition towards horizontal. Slow.
Yeah,
Keep going.
Yeah.
Alright, steady.
Right there?
Back it off about 2 or 3 degrees. Alright, now full horizontal.
Okay.
MECO at apoapsis of 90.
Okay, so kill the engines then?
Now.
Done.
Alright, let's plot our circ burn.
Okay, on map view. There we go. Come on, you silly thing. Man, it's sure hard to turn that little thing on, isn't it?
Indeed, sir.
Okay, let's see.
But it's useful once you get it.
Yep. Okay, that's probably enough, eh? We don't want to push too much.
Let's see the nav ball. We're talking about, call it 500, current loadout. So that means, ooh. Ooh. We're somewhere between 2 and 500 meters per second short.
All right. That's actually
Yeah, we're making progress here.
Shall we do a little design work off camera here and bring everybody back when we've figured out the final details?
That sounds like a plan, man. It's the final countdown.
Indeed it is. We've added a bit more fuel and we tweaked the settings on our thrust limiters. So here we go in 3, 2, 1. Lift off. And my wife texts me right when we're lifting off. She's probably wondering when I'm coming to
100.
bed. 70.
105.
90.
110.
100.
115.
110.
125.
120.
130.
130.
135.
Ejection.
That was perfect.
Full throttle. We are...
That was perfect.
Yeah. We're just losing... There, we've bottomed out.
Yep.
Yeah, so the setting, that setting just a smidge below 2/3 is right on the nose where we want to be.
Alright.
So we need to go not quite to 45 when we do our first turn, right?
That's correct. We need to remain a little bit more vertical than 45.
Yeah. Okay. Well, we're coming up on it here. Just a couple more seconds and we will make our turn. Here we go.
Who's the band that sings that song?
Final countdown?
Yeah.
You know what? I couldn't tell you off the top of my head. Alright, we are at 30, going to 35. How are we doing?
Looks good to me. Must be one of those big hair bands from the 80s.
Yeah, I'd have to look it up. All right, 40 degrees. I'll kick it. I think we can kick it over to 45 safely now. Yeah, we're into the 30-second time window now. But maybe we'll give it a few minutes.
The band's name was Europe.
Ah.
They're from Sweden.
Crazy. Oh, here's where we're into trouble. Our uppermost stage is not quite as powerful. See, we're losing time now. I've just got it. There we are.
Yeah.
I've just got us to equilibrium, just a little above 45 right now.
Good.
Okay. This time we're going to do it.
Yep. It was the final countdown.
Okay. So far, so good.
Ooh, use your ambient light adjustment to increase lighting. What are we doing?
I don't know.
Leftmost.
Here we are. How do we do
Slide that sucker.
Hey.
To the right, to the right.
There we go.
Our viewers thank us.
Indeed they do.
Or at the
okay.
very least, they stop cursing us.
Indeed. Oh, here we go. Upper stage. We should start going horizontal now, I think.
A little bit.
Yeah. Because I'm just looking at where we are on the... because we're over a minute to apoapsis now.
Alright. Ease it down.
Yeah. Still speeding up. We're about to cross the threshold to space on our apoapsis. And our time to apoapsis... There we go, over 70 kilometers, and we're going for about, what, 80?
85.
90? 85? Okay.
85, 90.
You don't need to be too high in orbit to get to the moon.
That's correct.
Okay, 81, 2, 3, 4, kill. All right, let's plan this burn. Kick that out so we can see them. That is way too much. That's okay. We can fix that.
I like it when you talk nerdy to me.
Okay, periapsis, right, periapsis. That's probably going to be good.
Back off the UT by 1 or 2 notches.
Okay, so sooner?
Yeah.
And then pull off some prograde?
No. Reverse the time increment. Go in the other direction.
Oh, go a little later?
Yeah.
Oh, there we go.
That's good, that's good.
Right there? Okay.
That is outstanding.
Okay.
We're gonna line up for that node.
Yep. Piece of cake.
Show them what
show them what this ship's made of. The little monster. That's what we should have called it.
That's right.
Okay. Getting ready to fire the engines.
Let's quick save.
Done. Just a standard quick save. I think. I can't actually see the text. There's so many windows in the way now. Alright, so we'll burn at T-minus 9 seconds.
Mm-hmm.
So did you want to recap what we've done today while we get this final burn done?
Yeah, we used a lot of discussion and trickery and test weights to figure out what would be necessary to get this on the ground on the moon with 1100 meters per second for itself, plus an additional 800 meters per second for its little friend. We tweaked the launch stage to get us back up into orbit, and it looks like we did pretty gosh darn well, if I do say so myself.
I think so.
The numbers on this one.
It's a nice one.
Yeah.
70, 80. Done.
Done. So,
Yes.
we're going to quick save.
Yep.
And we are going to say to the viewers, thanks for watching. Until the next episode.
Until the next episode. Thank you all very much for watching. We'll see you later.
Bye for now.